the network for commissioning for a particular application. That is the idea behind naming this protocol as infrastructure building protocol. It is a distributed protocol which enables a collection of sensor nodes to discover their neighbors and establish transmission reception schedules without any support, without any infrastructure, without any centralized agency. Right? So the two important phases are one is neighbor discovery and second is channel assignment. Right? So this is the introductory part. Now we shall continue. It assigns a channel to the link immediately after the link's existence is discovered. What does it mean? A node A detects its neighbor B, right? Then, because it is a neighbor, a channel is to be assigned. So, and that channel, right, that is the second phase. So they have agree upon a channel and a schedule. Right, links to begin this way. Links begin to form concurrently throughout the network. So all the nodes, neighbors, they do this job parallelly. And once they finish, now the links in the network are all ready for communication. By the time all nodes hear their neighbors, they would have formed a connected network. In a connected network, there exists at least one multi-hop path between any two distinct nodes. That is only possible when the network is connected, right? If there are partitions, then it is not possible. So we understand that. So this is the example we will take, right? So there are 5 nodes indicated in this simple illustration: A, B, C, A, B, C, D, and F. And a node which is not visible here is E, right? That is intentionally taken. So nodes A and D are neighbors, and B and C are neighbors. A and D, B and C neighbors. Now, how do they detect and how do detection is quite simple, quite obvious. They detect each other with the help of, with the exchange of hello and hello reply messages, right? So now the next part is how do they get assigned a channel, right? So the transmission reception pattern is repeated periodically for every T frame, right? That is the thing you should understand here. T frame is indicated. So the time the sensor nodes operate in the form of a fixed interval called a T frame, right? So here you can see the illustration. This is between A and D in the diagram. A and D neighbors, and this is B and C in the diagram. B and C are neighbors. So prior to that, you have to understand this node discovery phase, right? So node discovery phase, you understand here. So how this happens? So you can see there are 4 types of messages, 4 types of control messages. They are simply named as type 1, 2, 3, and 4. 4 types of messages. And this is like 4-way handshake. Right? Why do we need, we only know 2-way handshake, 3-way handshake, but why do we need 4-way? So here, the first thing is here between node C is initiating the process. So let's say it has sent type 1 messages. It is like invitation. Right? It is saying that I am node C and is there anyone around me? So now the neighbors between B and G is not indicated in the diagram. I said it is E, but here it is. They have taken this as E, G. Right? That's fine. Right? So it is disseminating invitation message called type 1. So both of them have received it. What is this point? This point, it woke up. Node C woke up and it has started. Now it has initiated the node discovery phase as part of the first phase. Right? So it has sent type 1. So node B and the other node G, which is not indicated in the diagram, like it is invisible, let us say. They took some time for processing that message and they have given the reply. So they express their interest, saying that yes, we are interested. Now this interval, this shaded part is waiting time. Right? So it has sent and then started waiting for the replies. Second reply, it has come at this point. Now it is processing it. And then it is said yes. It is saying it has expressed certain parameters. Like I want to use this channel and this is the protocol. This is like it is expressing its idea about the schedule. I want to start communication at this time, right? The packet size is this much, right? And these many packets I will exchange, right? So let's say it is like it is proposing a data communication. So if the proposal is acceptable for the node, then it can give the reply. If it is not acceptable, like any parameter is not acceptable to it because of its constraints, there won't be any reply. Now, node C have received the acceptance for the proposal. So now it communicates, it conforms with it, right? So at this time, it starts the communication. So now what is happening at the end now? These 4 types of message exchange, type 1 is broadcasted, type 2 are unicasted from each node. Again, it has broadcasted type 3. Again, it has received the unicast type 4. Now it has decided who is its neighbor. C has decided, determined that B is neighbor. Now they want to accept on the channel assignment. For that, you look at this diagram, above diagram, which is called as non-synchronous communication. It is not synchronous. Both will not be sending at the same time. Why? It is like only half duplex communication. So now let us see here. Node A and D, right? Node A and D, A and D find each other. Like say D woke up at this time, A woke up at this time, started, they have sent the messages, hello message, and now at this time both have decided, they have come to know that like with the help of this procedure, node discovery procedure, type 1, type 2, all these things, they have happened in this period. Now they have concluded that they are neighbors. Node B and C are neighbors. So here G has not replied, so C is not taking G as its neighbor because there is no confirmation. It has node might have dead, right? Or because of some parameter, it is not able to reach node C, right? Something may be preventing it, some bad weather or something, whatever may be the reason, right? So now by this time, A and D have discovered each other. Now it's time for channel assignment, second phase. So now they have decided during this time, they have exchanged schedules, right? So node D has decided the schedule like it wants to send first in half duplex way. So FX, right? So here it has sent, it is saying at this period I will be transmitting. Then as per the wireless networks convention, there should be gap between any 2 frames. So this is interframe gap, interframe spacing, IFS. Intentionally some gap is maintained. Otherwise the interference may occur because of the time lag. It sends and it may not be received at the same time. Here they are indicated at the same time. Time axis, both cannot happen at the same time. Instantaneously it cannot happen. There will be certain delay, certain latency that is not taken into account in this diagram, and that is accounted by this IFS, interframe spacing. So once this spacing is over, now it is using the same channel for transmission back, right? So this is it is sending one. It is using the frequency fx. Here fx is the frequency. Same frequency is used for reply. Now, like this say cycle, this alternation proceeds for a certain number of times. By that time, the super frame, T frame is nothing but super frame. Super frame is completed. Sending and receiving, this is one frame. Such frames are limited in number. A certain number of frames constitute a super frame, right? So this is how, right, the transmission schedule of nodes, two nodes, is expressed, right? So now this is repeated. Now again, next T frame is starting from here. So this is IFS, then it is transmitting. The other node is not transmitting but just receiving, and a gap is maintained. Again, it is responding back, replying using same frequency, same channel. So this is a transmission slot, and this is a reception slot. Same is the case here. Transmission slot with respect to node D, and with respect to node D, this is the reception slot, right? So that is how half duplex communication takes place. That is also called as non-synchronous communication. And here, A and B are also neighbor. B and C are also neighbors. So now A and B and C. B is neighbor to A and C. How they are accepting. So you can see here, right? They sometimes they may accept on one frequency for, right? So here, B, A and B, you can see. So B woke up at this time, C woke up at this time. They took this time to discover each other. By this time, they have discovered each other. So B and C have discovered that they are neighbors. Now this time is used for the schedule fixation. So they are using another channel FY. So this is the transmission slot of node B. It is transmitting, and now this has become, that is, it is in transmission mode, this is in listening mode, reception mode. Gap and same channel is used in the for reply. So this is transmission, this is reception. So here how many channels are indicated? 2 channels. So how FX is used by A and D, and F5, another frequency channel, another frequency is used by another pair of nodes. But here A and B are also common. How do they communicate? So A and B are common. So A is using one frequency for transmission, but using another frequency for reception. It means that A is using FX for transmission, B is using FY for transmission, but the schedules are fixed, but both are not happening at the same time. Right? So FX, right, FY. So then B and C, it is straightforward. The only thing is you should understand is how A and B use different frequencies for transmission, right? So B and C, yeah. So this is how the communication takes place. Now with this, you should be able to understand the 2 phases: node discovery and channel assignment and schedule fixation. Channel gets assigned and schedules for transmission reception are fixed. So once that is done, now the network is ready for communication. This is why this protocol, SMAX, is said to be infrastructure building protocol. I want to make a pause and take your doubts. There should be certain doubts, right? Otherwise, I can only say that you have not followed. Any doubts, please? No doubt? Yeah, come on, please.
Sir, I have a doubt about interval fixing.
Internal?
Interval, fixing the interval of communications.
It's not that clear. You want to refer to this illustration?
Yes, sir.
Yeah.
Here, what if node A is communicating with D and B also sends message at the same time?
Node D and B.
I mean, if D is communicating with A and also B is communicating with A at the same time.
At the same time, because it is possible because they are using different frequencies.
But won't it cause collision, sir, for it?
Frequency is different, so there is no interference, and that is not counted as collision.
Okay, sir. Okay.
Right. So if the same frequency is used, then there is interference, and that is named as collision.
Okay, sir.
Right. Right. Yeah. Any other doubt, please? Yeah. So this is to be understood clearly, and you should memorize it. You should read again so that you understand thoroughly. And examination point of view, this is also important. Right? Any other doubt, please?
Sir?
Yeah, please.
In the node discovery phase, you told that they exchange the type 3 control message change schedules.
Question is not clear. Probably poor signal. Is it possible to send chat message? Is it chatting is possible? You can just put some sentence, right? You can check the chart here. Just type one sentence. You can see. You are trying to type the message, please. No. Yeah. In the node discovery phase, you said they exchange schedules. Yeah, no. They in the node discovery it is not so. See here in the lower part, the figure B, they are only detecting each other, and they fix on the channel only, but schedules are fixed in the next diagram. You see here, this is non-synchronous communication, NSC, synchronization, non-synchronous communication. Right here, they are only accepting how much data they want to send. Right, it is like the proposal. This node is proposing, I want to have communication with you, and this is the amount of data. Right. So that proposal, if it is acceptable to it, then it is replying it. This is invitation broadcast. Nodes are responding. Then it is deciding, it is proposing the data communication, and to those nodes it is sending. Then if the proposal is acceptable to it, then it is responding. If both of them respond, only one is picked, and with respect to one channel is assigned. With respect to another time, right, you should try another proposal with another neighbor. Right. So again, like it is establishing channel one by one. It's not parallelly. If there are two neighbors, 2 attempts are necessary. This exchange of these messages, right? Because they cannot use the same channel. The different channel is to be used. So once they detect each other, then this part starts. This is channel assignment part, which is based on NSC, non-synchronous communication. Here the schedules are accepted. So it is saying, what D is saying that first it is going to transmit. The other one has to be in the reception mode. Then again, after ensuring the gap to avoid the interference, the roles are switched. Right? So this is to be understood. Is it clear?
Yes, sir.
Yeah. Any other doubt, please? Okay.
I have one
Yeah,
more doubt.
please.
Sir, when two nodes are communicating, they communicate in duplex, right?
Half duplex.
So if they fix two different frequencies, then they can communicate in full duplex, right? At the same time.
Yeah, see, when neighbors are deciding, right, they usually it is half duplex because when they are sharing the same channel, if they are using two different channels, it will become duplex. We have seen in the diagram, right? A is communicating with B is communicating with A, right? In the diagram, you can see here. This B is fortunate to have duplex communication with A, right? A and B particularly. But whereas A and D and B and C, it is going only half duplex. Why? Because they are using the same channel for sending and reception. But here it is for sending one channel, for reception some other channel. Where A is using frequency fx, but B is responding with fy. Right? So that's why it's possible. But usually it is half duplex. Only one node at a time. That's why we say non-synchronous. Right?
Is there any benefit of half duplex, sir?
Is
there any benefit of half duplex communication or full duplex?
Is it benefit you are saying?
Yes, sir. Is there any benefit?
No. See, definitely half duplex is inferior to full duplex. It is definitely inferior. It cannot be advantageous, no? Because channels are limited. There is only one channel between every pair. So they can and allowing the other, right? Then that is why it is non-synchronous or half duplex. But whereas if you have different channels, no, for transmission and reception, they can go in a full duplex way, no. That is more versatile solution. Whereas this is not that versatile, right? Okay, not clear?
Clear, sir.
Good. Any other, please? Any other doubt, please? Yeah, then we'll go to the next concept. So there are some more MAC protocol. So as it is not possible to discuss everything in online class, so selectively I have discussed SMAC and SMACs. And there are a couple of MAC protocols, other MAC protocols. You are advised or you are instructed to go through on your own. Now it's time to switch to layer 3. What is layer 3? Layer 3 is network layer. The important activity is 42 students. Still some students are joining. I don't know what will they do by joining. Okay, next layer is routing layer, layer 3. The network layer, its important function is routing, right? So let us discuss this routing. Yeah. So why you may say one point. The point is why should we discuss routing? Having discussed the right. Having discussed the routing for manets. Why manets? The wireless sensor networks are special case of manets. Then whatever we have discussed for manets should be applicable for wireless sensor networks. Is that okay? No, because sensor networks have their own characteristics which are distinct totally. The thing is, there is no mobility at all. The first striking difference. Second thing is, they have very narrow resources, very limited resources. Second, decisive factor. And the third one is very important. And there is its life is limited. Things which make us to have different routing algorithms, or the existing routing algorithms doesn't work for sensor networks, right? So that is the first thing. Routing in sensor networks is usually multi-hop. The goal is to send data from this data source to destination, that is sync. The destination node or sync node is addressed by means of its location. The base station is always equipped with a technology like GPS, Global Positioning System. So it knows its location, and that location is disseminated to all the sensor nodes. Wherever this condition is valid, or whenever a node becomes a data source. Why that node becomes data source? Because an event is detected by that node, right? So the base station may be fixed or mobile and is capable of connecting the sensor network to an existing infrastructure where user can have access to the collected data. What this point says is, I am referring to this particular diagram, this one. So here, this base station, what is happening? It is like the gateway between these two. This is one world where the sensors are deployed in a wide area and far away. They are very dear. So probably this is unreachable area, maybe dense forest or a mountainous area, right? Or a chemical plant where the human presence is risky. But this side is, you have wide range network. Wide range means the network presence is quite abundant. It's not a problem. We have the internet and other facilities. So this base station is the gateway between these two. That is the point that is made. Right? Yeah. So routing layer. First thing is, you should understand that wireless sensor networks demands special treatment, special application of special implementation of routing layer. Why? Because of its own set of characteristics as mentioned now. So now once you understand that point, then you can look at this. In the literature, so many people have done the work, so many people have done the research work, and they have come up with so many protocols, and that has resulted in a very generalized, right? Very generalized taxonomy. So when the literature is too vast, so how to approach and understand the existing literature? The best way is getting the algorithms classified or based on certain criteria. So once that is done, you can simplify the existing literature. So people have done that, and they have come up with this taxonomy. So routing schemes for wireless sensor networks, they have taken two criteria. What is the network structure? How the nodes operate, right? Based on that, say there is one set of algorithms. Now, same algorithms, same the literature, if you look at from the different perspective, then you can classify in different way. That is what is the principle of operation of the protocol. Based on that, you can categorize the same algorithms in different categories. So this taxonomy is distinct from the usual taxonomies, right? It is not like, when you give me one protocol, you can fix it in one place. No, it is not possible. If one protocol is given, for example, directed diffusion comes under flat-based routing. It also comes under negotiation-based. It also comes under query-based protocol. Query-based, right? So the same protocol becomes the example in two categories. So this taxonomy is not mutually if you take routing. No, you say this is it is not so. Same set of, we have taken two set of algorithms, and understood or studied those that literature based on two distinct criteria. First one is network structure. Structure, you are saying, not the topology. Network structure. For communication, what structuring is done, right? So based on that, this classification has come flat. There is no hierarchy. Non-hierarchy, you can say, flat based. So this is hierarchy based. I have said, right? Leaf nodes, cluster heads. Based on that cluster heads, you have one more level. Then at top level, you have the base station. Leaf level, there's nodes which does only sensing job. Top level, level 1, it is the base station. So this is one taxonomy. Then the same set of protocols, if they are discussed based on some distinct criteria, like what is the principle of operation, mechanism. So then you get this classification. What is that? Negotiation base. Is there any negotiation? Like example is spin protocols. Sensor protocols for information dissemination via negotiation. Right? That is spin. Multi-path based. You want to have between source, data source and the same multiple paths for the reasons of reliability or for the reasons of performance. Either for any reason, you have multiple paths between the data sources and the sink. That is multi-path based. Then the next is query based. So when is it the query that is triggering the network into operation? Based on that, it's a query based routine. And the last one is location based. Now you want to critically use the location information. Where is that? Based on that, if the protocol is working, then it is called as location based protocol. So now a summary of this is routing schemes for wireless sensor networks are categorized as based on network structure and based on protocol operation. Based on the network structure, further classification is flat, hierarchical and adaptive. Adaptive, please remember here, the protocols on their own, they understand the parameters of the system and change their operation accordingly. Right? Yeah, 1 second. I will have a glass of water. సార్ ఒక 10 నిమిషాల క్లాస్ అయిపోతే కాల్ చేస్తానండి. సారీ. So I'm sorry, we shall continue. Yeah. So this is the classification one must understand. So first classification is, remember, this is distinct from our usual classification. It is not mutually exclusive. There is the same set of protocols discussed under two headings. One is network structure, the other is protocol operation. So network structure, the flat base, all nodes are equal, they play same role. So that is flat base routing. All nodes will have same role. That is sensing, processing and forwarding. So same, right? Whereas hierarchical, it is not so. So there is some hierarchy, there is some clustering. Right? Then next is adaptive. Adaptive. So the network, the routing protocol starts its operation and changes its behavior based on certain parameters. For example, a group of nodes, they form a cluster and one of them is elected as cluster head. Now after some time, this cluster head ship is rotated. That is, someone else will take over as cluster head. How is it happening? Protocol has got that feature. That is, if the node energy levels are falling below the threshold, lower threshold, then that node will initiate the transfer of headship. Some other node is named by it. Whoever has got maximum battery energy, maximum power, maximum energy, that is named as, in one case, there are other criteria, like if the energy is equal, so many nodes are competing, who is to be named? Yes, right? So that is based on certain criteria, certain strategy, the headship is changed. It's not only headship, even sometimes clustering may also reorganize it, right? So that is what we mean by adaptive. Then different criteria, protocol operation. What is the principle of operation of the protocol? First one, is it the negotiation that is happening before routing? Yes, if that is the case, this is a negotiation-based routing protocol. And multipath-based routing between data source and the sink, why do you want to have more than one path? Simple reason. One is for reliability. Right, same data is routed in multiple directions, so reliability is ensured. Or the data is partitioned and one part is sent on route 1, another part on route 2, like that, for better performance. So whatever may be the driving reason, we want to have multiple paths between source, data sources and the sink. And the next one is query-based processing. So query-based processing, if the query is diffused, then as a result of it, the data is gathered, right? The physical parameters are sensed, and then information gathering is done and protocol processing is done. That is query-based, right? Then the location-based. Here, the location of the node is very important for deciding the routing activity. So this is the broad classification. Now we shall start with one simple protocol that is based on flat routing, right? So in all nodes play the same role, right? All nodes play the same role. That is very important, right? That is flat, right? Yeah, so that is flat. So best example for this is a very popular protocol and very important even from the examination point of view, directed diffusion. What is this protocol? It is a flat protocol. All nodes have the same role to play in the given network. Then how directed diffusion routing algorithm is applicable? What is it? It is a data aggregation and dissemination paradigm, right? It is based on data-centric. So you should understand every sensor network is based on data-centric. It is attribute addressing based, right? And application-aware approach is used. It means that data generated by sensor nodes is named by attribute value base. It is already mentioned. It is right. It is not necessary. We have already discussed this point. So attribute addressing, sensor nodes are identified based on the attribute name and a specific value t, 35 degrees. This is one ordered way. If this is given to each and every query, each and every sensor node, then some of them get triggered and they communicate. Why? Because there the temperature that is sensed is greater than or equal to 35 degrees Celsius. So that is how those nodes are identified. That is what we mean by data-centric attribute addressing, right? Not address-based, right? The second thing, this protocol is very useful for applications where dissemination and query processing is essential, right? So queries, who is giving the query, to whom it is given? Query is given by the base station. So it is diffused. That is, a flooding-based broadcast approach is used, right? You can understand that in the diagram. Yeah. So here the base station is indicated. This is diffusing. It has set broadcast, so its neighbors receive it, right? And this is again repeating, forwarding further. So From this again 3 nodes are getting data. Here nodes are getting the redundant data. Same query, this node is getting the same query through this node or through this node, right? So redundancy is unavoidable, right, in directed diffusion, right? Then what is the other point you should understand, right? That is the first part, data, that is query diffusion. Once the query diffusion is over, right, then what is the next point? Next point is how the sources are identified. So the first part you should understand is query diffusion. The base station prepares, the sink has got a query, it desires, it is intended to collect some data. It has framed, query is formed, is framed by base station, and that is diffused into the network. Here in this diagram, the redundancy part is avoided. So thereby you could able to see this diagram as simple. Otherwise, if you indicate all possible communication, then it becomes more clumsy. To avoid that, it is kept simple by indicating only the required information. So sink has sent a query, right? The sink has diffused a query. All the nodes are receiving it only once here, but in practice, it is not so. They will receive multiple times, right? But second time onwards, it is going to be discarded. For the first time, it will respond. If it is not the data source, it forwards further, right? So like that, the query is diffused. Let's say this node where the query has become satisfied. Now that becomes the data source. So from data source, the routes which are established from the base, from the sink to the source, are now reversed. Right? So that is, you should understand that point in terms of changes in their routing tables. Whatever the routing table that is maintained, or at least what it is maintained with respect to a particular source or particular destination, what it has to respond in the second part. Here, the directions are reversed towards the sink. Here, the directions are towards the data sources, but it has no idea which nodes are data sources. But the source node, once it identifies itself as a source node, it has an idea where the sink is. So whatever the data is, it is ensuring that it reaches in more than one way for reliability purpose. Same data is received again and again, that's not a problem. But some data is lost, that becomes problem. So that is second thing. And what is the importance of the third diagram? Third diagram is, so in the second diagram, what the paths are established from multiple sources to the single sink. But if there are multiple paths, what is to be done? So data source has to pick the best route based on the shortest path, based on certain criteria. Shortest path can be number of hops, or it can be the bandwidth that is utilized, that is minimum bandwidth you want to make it utilized, or the delay, right? Like that, no, you can always change the parameter, right? So now it is selecting, data source has selected the best route. Now it starts sending the data, and it is observing the data, and it is keeping track of acknowledgements. So based on that, it is say recording the condition of the current route. What for? It is keeping an observation on that link, on that route, that, right? If everything is working perfectly, it increases its priority. Right, the priority of the route is incremented, right, and more data is sent toward the same route. But let us say somewhere some problem has occurred, some node has moved, and a particular node is unable to send the delivery. So that is eventually there will be timeout at source, right? So then then the same concept called reinforcement will occur. In the previous case also, when everything is working as expected, it applies the positive reinforcement. And in the second case, suppose somewhere something went wrong and then suddenly there is a packet loss, right? So then it is going to apply the same reinforcement concept with negative, right? Negative reinforcement occurs. That is, now the priority of this route is decremented, and meanwhile source will try to find out an alternate route. If necessary, it may repair the route in the existing route. Some part is erroneous, that part will be corrected, right? In the case of corrected means what? Suppose this route is not good, now it may find alternate route to reach the sink, right? That is the point you should understand. That is what is a negative reinforcement. So when the transmission is taking place, you can always keep a close watch. When everything is working perfectly, then you increase your priority. When suddenly some thing goes wrong, its priority started decrementing. And meanwhile, you also find the alternate route, right? So that is what happens, that is what it is intended to explain from this diagram. So please remember, sensor networks, whenever you say you want to design the protocol, please remember you should always say the sensor protocols are application dependent. What is application? Then if it is a temperature application, I will give you one set of routing protocol. If it is commercial application, I will give you some other routing algorithm. So the routing protocols for wireless sensor networks are application dependent, are application aware. That is an important point you should understand, right? So then another thing is the network structure based, right? It is network structure concept and it is continued. So when it is continued here, what I am trying to say is, how do you identify the data sources? Is it always single node? Is it always a single node where the event has occurred? I'm sorry, where the event is detected? No, it is not like that. So there are two models. One is, right, so one is event radius model. Here, let us say the event has occurred at this central node. So all these surrounded nodes are treated as is taken as all the nodes surrounding that neighbors, neighbors, they are considered as data sources. So only one node has detected it. Still, the cluster to which it belongs is identified, and all the nodes in that cluster are made data sources. They have to start sensing and send the result back to the sync node. So this is what you say event radius. So all the nodes within the radius limit R, suppose event radius is small r, all the nodes within the reach less than or equal to this radius R, then they are all considered as data sources, right? So this is the first model, and here all the sources are dense, they're close to each other, and there is no such rule as such. So here the sensor nodes may get scattered, right? But the condition holds good at these 3 points only, right? So thereby they are the data sources. This is called random source model. The difference is event radius data, the event has occurred at central node, all its neighbors will become data sources. Here random sources model, the sources itself, they are random, right? They are scattered throughout the network, and from them the data is collected, processed and forwarded towards the base station. This is what you say event radius models are models in directed distribution. Right, this is another algorithm. So try to understand this. Do you have any doubt in this directed diffusion? Any doubt, please? So if there are no doubts, and I would like to close this discussion on directed diffusion, right? So, yeah, so thank you. So in this class, what is that we have discussed? We have completed SMAC's MAC protocol and started discussing, or we have completed directed diffusion, a flat routing protocol for wireless sensor networks. Please remember, flat is relatively complex. Directed diffusion, which is a flat routing protocol. Directed diffusion, there is a concept called reinforcement, and there is a concept called radius model, data source model. So having understood, right, you can better understand the directed diffusion protocol. So now it's time for queries. If there are no queries, the students who don't have any queries, they can close the meeting. Right? Those who have the doubts, they can stay back. So others, please close. Good day. Thank you, one and all. Thank you, one and all. Thank you. Please close. Good day. I have collected the attendance already.